Good afternoon, everyone. My name is Ned Cake. I'm your moderator for this afternoon's session, Understanding Basic Computer Components and GIS Specs by Tripp Corbin. Once again, welcome to SHRUG 2020 Virtual Workshop. We're also glad that you can make it. As I mentioned in other sessions, this session is being recorded and will be available after the conference or the workshop is over. Tripp has said that you may enter questions and I'll interrupt him along the way. If he's talking about a specific subject and you have a question about it, feel free to type something in the question chat area and I will respond to them as quickly as you add them in. That said, I'm going to hand things over to Tripp and let him get started. Hold on just a second, Tripp, and I'll make you presenter. You are now presenter.
Okie doke, sounds good here. And trying to, which screen are you seeing?
Oh, I have to hit the yes button to turn it over to you, sorry.
Oh, there we go. So now I was like, okay, which one is it? Okie dokie, and that one should work. So can everybody see my screen now?
I can see your screen.
Very good. It's advancing.
I'm going to mute until you have some questions.
Sounds good. Well, folks, welcome to our virtual conference workshop. Glad to have everybody here. Wish it could be in person. Really miss that in-person interaction with everybody. So for those that don't know me, as Ned was saying, my name is Tripp Corbin. I've got over 25 years working in the geospatial field, from surveying to working with AutoCAD and of course all the Esri products. And I also spent 5 to 6, 7 years as an IT guy. So I was that dreaded network administrator, systems engineer that tells you when you have a problem, did you reboot your system? Sorry, you can't install that because it's against company policy. Sorry, that website's blocked. That wonderful guy that you all love, right? That IT guy. So, but what that did do is it gave me a good understanding of all the hardware, networking capability, all those things that we rely on to run our GIS software, to analyze our data, and so on. And now, as our software continues to grow and expand in functionality and capability, the data sets we work with continue to grow and expand in size and scope. It's really becoming important that we are able to talk computers with our IT people, because the computers that we were using last year, year before, and back just are not going to have the capability, the horsepower needed to run the new applications that are coming out, things like ArcGIS Pro and so on. So we want to make sure that we understand what those basic parts of a computer are, what they do, and what we really need to communicate back to IT or purchasing or whoever we're working with when we have to order a new system, so that we ensure we get a computer that actually has enough oomph in it to run current applications as well as any future applications that we see coming on the horizon. Because I can tell you right now that if just because your computer, and I'm going to use Esri software as the primary example because that's what I'm most familiar with, but just because your computer is capable of running ArcMap and ArcCatalog now without a whole lot of issue, that doesn't mean that it will run things like ArcGIS Pro successfully, because these new applications have a lot broader hardware requirement in order to support all the new capabilities that they bring to the table. So you really do need to be able to talk computers in a way that shows you have an understanding of it and can be able to communicate more directly with the IT people and the purchasing people, so you can explain why the same basic system that you've been buying for the past 5 years doesn't necessarily work anymore as we move into the future. So that's what I really want to do. Make sure you understand all these basic parts that make up a computer, and know that I'm speaking from some level of experience, and that the system that I'm using right now to do the meeting on and that I run my GIS is one I built myself. I built it all from scratch. So I do have some understanding of what these things are. And if you've never built a computer, they're really kind of fun to do if you like to build things. So in general, all computers, whether that's a desktop or a laptop or even a tablet, have the same basic components, the same basic parts, right? You're going to have a case, the stuff that everything fits into. Now that may be a big case, and if we're talking about a desktop, it may be, if it's a tablet, it's a really bitty small case in there, right? They're all going to have a power supply, that thing that takes power input from your wall or your charger and disseminates it to the various components in the system. You're going to have a motherboard, right? The foundation of the system, a processor, memory, storage, display capacity of some sort, and some sort of input, mouse, keyboard, and that kind of thing. Now, by and large, if you're having to order from a vendor, be that like Dell or HP or Lenovo or so on, some of these things you're not going to be able to control. You're not going to be able to pick a case. Now you may be able to, based on the model you choose, pick the size of the case and somewhat the layout. So if it's a desktop, is it a full tower, a mid tower, more of a, I call it a small form factor type case on there, but the vendor is going to choose it based on the model. Same with laptops and tablets, obviously you're not going to pick those. Same with power supplies. Power supply is going to be determined by the vendor you're buying the computer based off the components that you need to get. Now this is one, I'm going to raise a caveat to this that is fairly new. And that is, right now in the world of computer components, there are several big launches of new product that have either already happened or about to happen. And that includes new graphics cards. Very powerful graphics cards are coming out, and new CPUs are coming out. These all have much higher power requirements. So if you're going to be, and we'll talk about some of these in more detail a little bit, if you're going to be utilizing some of these newer products that are coming out as part of your specification, you may want to make sure that there's enough power from the power supply to support those. And we'll go into a little bit more detail about that later, but it is probably a concern, and I'm not sure, based on what I've seen on the various groups I'm part of and YouTube channels I watch, if some of the hardware manufacturers, and I should say systems integrators, those people like HP and Dell that build systems, are necessarily ready for the new power requirements that are coming out. So it's something you may need to watch. Other things, you're not going to be able to specify a specific motherboard if you buy from one of these systems integrators like Dell and whatnot. If you do go to buy your own or build your own system, then yeah, you can pick your own motherboard, which is kind of nice. But the other things you will be able to have some control of is specifying what processor you use, the amount of memory you use, and the speed that memory runs at, the storage included in your system, not just in size, that is obviously important, but also the type of storage. And it's not like the old days where you just ordered a hard drive. I need a 1 terabyte hard drive and you're good. Now we have a lot more options when it concerns storage in our systems. The types of storage, the speed of the storage, how much storage we put into it, and how many different storage devices we include. So we'll talk a good bit about that. And display, obviously we've got some options on display. Now if you pick a tablet, like an iPad, then you don't have a lot of control. You get whatever comes with that version of the iPad you choose, but same with laptops. But if you start getting into desktops, then there's a lot of options there for display that we'll get into a good bit. And then I'm not going to really touch on input devices, mouse, keyboard. Y'all should be able to handle those things. And typically that's not a big deal as far as specs on trying to communicate with IT on what you need. So, Ned, we got any questions so far? Everything seemed to be following along?
So far, no questions. You guys be sure to put the questions out there if you have them. Thanks.
Good. Either they're already lost or we haven't gotten anything they don't know yet, which we'll see. So we're going to start here and talk a little bit about the motherboard. And as I said, if you're buying from, a Dell or HP or that kind of thing, you don't really get to choose which motherboard you get, but there are components or specs for the motherboard you can choose or verify when you're trying to pick which model that you want to select to use as your new workstation. So one of the first things you want to look at is memory. How much memory does the board support is the first concern. So obviously, with modern applications, the more RAM, random access memory you have, the better. So you don't want to get a board that is, or a system that is limited to a small amount of RAM, right? You typically are going to want to make sure your system can support at least up to, not that you'll necessarily start there, but up to 32 gigabytes of RAM. More is better. So if you can support up to bigger than that, that's great, but at least 32 gigabytes of RAM, you want to make sure your board is capable of supporting. The other part we want to look at when we're talking about memory supported on the motherboard is the number of channels. And you may think, well, what do you mean channels? It's memory. What are you talking about? Well, if you look at the screen, the screenshot here of the motherboard, this is the motherboard that I put in the system I built. And you can see there's 4 memory slots. Let's see if I can use the wonderful pen here. So this right here, circling there, are the memory slots, or the slots for RAM on this motherboard. And you can see that there's 4 of them. And I'm sitting here doing hand gestures that you can't see. But anyway, you can see there's 4 slots. That means I can put 4 memory sticks onto this motherboard. Now, getting back to the idea I was talking about with channels, what does that mean? Well, I can see because there are 4 slots, I know that a channel takes up 2 slots. So I know I have dual channel memory because I've got 4 slots. I've got dual channel memory on this motherboard, which is what you want for a workstation. Now, if you're just doing a laptop for demos and things, or basic training, that you don't necessarily need dual channel. But for a workstation where you're doing analysis and you're doing data edits and all those kind of things, you want to make sure you have dual channel. Now, how do you tell this when you're looking at a picture of a Dell computer on the screen on the Dell website? Because they don't show you pictures of the motherboard. And that's a great question. What you want to do is look at the total number of memory sticks supported. If it says 4 by 8, which would be 4 sticks at 8 gigabytes a piece, or 4 by 16, or whatever, that 4 by. If it says 2 by something, that means it only supports 2 sticks of memory. That means it's single channel. And why is this important when we look at double channel versus single channel? Well, a channel is, if you think of it like a highway, a channel would be a lane on the road. So obviously, twice as many lanes can support twice as much traffic. And that lane is really the pathway that all the components, primarily the processor, use to access that memory. So obviously, the more paths it can get to that memory, the faster it's going to run, and the quicker things are going to get done as you running through those. It also increases the amount of memory that can be supported by the motherboard. So that's an important thing to take note of when you're looking at the various systems, is how many total sticks of memory can that particular system support. The other things you want to look at on here is the number of connections that it supports and what types of connections are those. So I think most of us probably connect some sort of USB device to our computers, whether that's the keyboard and the mouse, or whether it's plugging in some GPS unit, or whether it's connecting external drives, connecting other display device, whatever it is. We all connect various USB devices to our machines. So we need to look at how many connections does that system support, and those are all based on the motherboard. And then not only how many, but what types. So when we talk about USB, there's more than one kind of USB. We have USB 2.0, USB 3, USB-C, and even in USB 3, there's 3.0, 3.1, 3.2, 3.2a, and now they're talking about USB 4. So we need to look at, how many connections do we need? And whatever you think you need, make sure you have a few extras, because you never know what's going to be coming down the pike for extra connection types. And then where are they? Are they on the back of the computer, on the front of the computer? So if you want to plug in an external hard drive that you use to transfer files, maybe from home to work or whatnot, or between two computers, then you want to, that may need to be a front panel USB connection. Or if it's a device like your mouse and keyboard that you always leave plugged in, that can be plugged into the back of the computer, because you're not unplugging and replugging them all. So you need to make sure you pay attention to that. And of course, another big important connection type to be aware of is what type of networking does the motherboard support? Does the system support? Is it Wi-Fi? Is it just Ethernet? Is it Wi-Fi and Ethernet? If it's Wi-Fi, is it type G, type B, type N? What type of Wi-Fi does it support if you're going that route? And of course, if it's Ethernet, is it 10 base T, 100 base T, gigabit, or now I think they have 10 and 20 gigabit Ethernet connections in there as well. So again, you want to verify that. And of course, a lot of that's going to also be limited by your own internal network there. But these are definitely things that you need to be aware of. Now, from a GIS perspective, I've already kind of mentioned what you want for memory. Connections, that's going to be dependent on what types of devices you plan to connect and what you need to plug into them. Networking, I would say you want to support as high a level as possible, even if your current network infrastructure doesn't support it. So if you have the budget to get a 20 gigabyte connection on your system, even though your current network is only gigabit, that just helps future-proof you if you can do that. I wouldn't suggest for a GIS computer you get anything less than gigabit, which you'd be hard-pressed to find a modern system that didn't do gigabit. But again, just something to be aware of. Okay, so these are all things that you need to think about that are tied into the motherboard. These are components that are there either in ports that are going to be located back here on the I/O panel that's usually at the back of the computer, or through various headers located on the motherboard like here. These would be like USB headers that you plug in for your front panel connections and those kind of things. Okay, let's get out of the drawing and back to here. Okay. So now we'll jump into your processor, the brain of your computer, the thing that does most of the heavy lifting. Okay. So when you're looking at a new computer, more than likely your CPU is either going to be Intel or AMD. There are a couple other manufacturers like Apple just came out with their new M1 processor. I have not had a chance to look at that. But by and large, most of them come from Intel and AMD. So when you're looking at that, there's a lot of different things you need to consider when picking which one you need to go with. So part of this is going to depend on what software applications you're running. So this is where you need to kind of understand what software is capable of. So again, sticking kind of with the Esri products, because that's what I'm familiar with. If all you're going to be doing is running ArcMap in Arc Catalog and necessarily ArcScene, ArcGlobe, those older applications from Esri, then those were all originally designed around the late 1990s. Matter of fact, ArcMap came out in 1999 originally. So they were built at a time when computer software was really outpacing computer hardware. And now the reverse is true. Hardware has outpaced the capabilities of the software by and large. So what that means, and why I'm mentioning that, is ArcMap and associated are 32-bit applications. Okay? So there's some things, and we'll talk about this a little bit more, get into memory, but there's some limitations on what ArcMap is capable of doing, and ArcScene, ArcGlobe, ArcCatalog as well, because of their age. One of those is something called hyperthreading. ArcMap, ArcScene, ArcGlobe, and all that don't really support hyperthreading. And you may have no idea what I'm talking about when I'm using that word. What that means is when ArcMap came out, most computers that were not servers had a single processor, single core setup, meaning that everything ran through one processor, and that was your OS, your software apps you were running, everything was running through that one processor. Nowadays, CPUs have multiple cores, which in essence means on your single processing chip, there's multiple mini processors on there, for lack of a better understanding. I don't want to get too technical, but in essence, that's what it means. ArcMap is still only designed to run in basically a single core, single thread mode. Meaning even if you have a modern processor, like one of the new Ryzen 5000 series processors that just came out the other week, well, they go from, 6 cores all the way up to 16 cores, depending on which model you're getting. ArcMap is only going to use one. So even if you get the low end 5600X Ryzen 5 processor, even though it has 6 cores, ArcMap is only going to be able to use 1 core and 1 thread on that. So it's not going to be able to really take advantage of that chip, which means what you want to focus on is a CPU that provides the best single core performance than a multi-core performance, which has meant up until the release of Ryzen's new 5000 series processors that Intel was the best way to go if all you're doing is running ArcMap, because ArcMap is designed for single core process, and Intel has led the way up until this recent release by AMD on single core performance. Okay, so that meant up until, like I said, up until like 2 weeks ago, Intel was the way to go if you're running, say, ArcMap. Now, ArcGIS Pro, on the other hand, is designed to support hyperthreading, that ability to utilize all of those different cores on a single CPU. So if you were running the Ryzen 5 5600X with its 6 cores, Arc Pro is going to be able to utilize those. But it'll also make use of the Intel. So if you look at the current Intel 10th generation processors, say the i5, which is the lowest one I would go with, you're looking at 5 cores. Okay, so a little bit less than AMD, but you would be able to utilize those. So if you're going to be running both ArcMap and ArcGIS Pro at the same time, but primarily in ArcMap, then you might want to, and you plan to stay that way for a while, you might want to look at getting the Intel processor. Whereas if you're going to spend most of your time in ArcGIS Pro, and knowing the new values that are coming out from Ryzen, you might want to look at a system that would be powered by the new Ryzen chips from AMD, the 5000 series, because they're going to give you the best performance per dollar currently on the market. Now, this may change. Intel is set to release, there we go, a new series of processors sometime the first quarter of next year. So we don't really know the full performance specs of those. Some things have been leaked, but until we see them and benchmarks have been tested, we won't really know how those rack up against the new AMD Ryzen chips, but things you need to look at. The other part with the CPUs you need to pay attention to is the amount of cache that's on those. So cache is onboard memory that is there with the processor. It's very, very high speed memory, much faster than RAM and a heck of a lot faster than any sort of hard drive or storage, other storage on your system. So the more cache on the chip, the better there. So that's something else to consider. And then tied back into the cores is the idea of clock speed. And that's how we basically measure the speed of the CPU enable to process instructions or requests on there. So the higher the number, the better. But usually you're going to get two numbers when you're looking at that. There is the called the standard clock speed, and then there's going to be like a turbo clock speed. So the standard clock speed is what it will typically run at regardless of what's happening. The turbo clock speed is what it'll ramp up to. It's kind of like, I'm kind of a car guy. I'm working on restoring a 67 Mustang right now. So, I think of it kind of like either having a turbo on the car or kind of a nitrous system on the car. When you hit it, everything speeds up very fast. So the same thing here with the turbo clock speeds on the various processors. It's what, when you start putting the system under load, it will ramp up to. However, it will only maintain that speed based on other thresholds like temperature. The faster the CPU runs, the hotter it gets. And so as it gets hotter, the system will automatically throttle down the clock speed to reduce the heat, because heat is the enemy of a computer, especially the processor and the graphics processor we'll talk about in a little bit. So we'll see that turbo speed start to come back down to the standard speed or the regular speed as the heat builds up. So that's another thing I don't think I mentioned here that you might want to look at too. If you know you're going to be doing a lot of processing, then you want high clock speeds, then you need to look at how is the system cooled. And there's two basic ways that systems are cooled. There's air cooled through heat pipes, there we go, heat pipes and fans, or you can actually water cool or liquid cool a system. And you can also get into things like liquid nitrogen, and you're not going to have that at your office. But liquid cooling, liquid cooling typically provides better cooling than air-cooled in most cases. And that's kind of also a pun because it depends on the airflow through the case. But my system that I built, I'm running liquid cooling on my CPU to keep those temperatures down. So when I'm processing LiDAR data or doing some sort of raster analysis or something, that processor is able to run as fast as it can, as long as it can, so it doesn't get thermally throttled as a result of that. I probably started causing brain cells to bust and headaches to form with all this I'm throwing at you. And, I hope not. I'm just trying to educate y'all on some things that you need to know.
So far, so good.
So far, so good. No questions. Either I've overwhelmed everybody or their brain just hurts already and they have no idea what questions to ask.
Or they're afraid to ask. Don't be
Or they're
afraid.
afraid.
Ask a question.
Yes, please ask questions. I'm not sure I'll know the answer, but we'll give it our best shot. Okay. There we go. So now let's talk about memory, that random access memory, RAM, in your system. So this is certainly something we need to be cognizant of, and there's several things. Obviously, the amount. I would tell you right now for any GIS workstation that you don't want to be running anything less than 16 gigabytes of RAM. Most apps like ArcGIS Pro say they will run at 8. I've tried running them at 8. It was not a very good experience. I've done that with QGIS a little bit. I've played in that space some, and even it doesn't particularly like 8 gigabytes or less of RAM. So definitely you want to make sure. Go ahead.
We do have a question now.
Oh, shoot.
From Scott Weissman. Will NVIDIA video cards work properly with Intel CPUs?
Good question, Scott. And will NVIDIA video cards work well with Intel CPUs? Yes. NVIDIA graphics cards will run with either AMD CPUs or Intel. In the past, there has been no performance gain if you pair a Intel CPU with an NVIDIA graphics card, or an Intel CPU with an AMD graphics card, or even an AMD CPU with an AMD graphics card. And I say that as far as in the past, because AMD, in addition to just releasing the new Ryzen CPU, is just about to release a new GPU, or graphics processor video card. Now, these cards, these new graphics cards, support something they're calling smart memory access, or smart access memory, something like that, SAM, I guess what it is, which allows an AMD CPU a direct access to all of the memory on an AMD GPU, instead of a limited pipeline of access at 256 megabytes at a time of memory on the GPU. So in theory, with the new Ryzen 5000 series CPUs and the new 6000 series GPUs, there could be some performance gains, that's what I meant to say, by pairing AMD with AMD. But from what I've seen from the current benchmarks that have started coming out on the new Ryzen graphics cards, that performance gain is only about 3 to 5% over running, say, an Intel processor with an AMD video card.
So Scott has a follow-up question to that.
Okay.
It used to be that AMD graphics didn't work well with Intel, so that's no longer the case? Question. I have lots of other questions now too.
Okay. So no, for the current generation of, and even the generation back, the 5700 series of AMD graphics cards, they work fine with Intel processors. The thing that's been, I guess, the problem with AMD in the past was not necessarily direct conflict between Intel and AMD. It was drivers. AMD would release their graphics cards with bad drivers that really weren't fully vetted. And it usually took 6 months for them to get all the issues ironed out. But there's no real issue there.
So next up, Maria Marquez has a comment. This is very informative for me. Thank you. I'm new to GIS and I want to know what I need to look for in a system.
Okay, good. Glad this is helping. You have any more questions?
Let's see. What are the specs of the computer you built?
What are the specs of the computer I built? Let me go through all this, and at the end, I'll give those specs out. I actually have a YouTube video that goes through me building the whole system.
And one more from Scott. What do you see SRI products working best on?
I'm gonna say it really depends on what you're trying to do. Typically, the AMD products have been best with straight data processing. That's changing, and again, it depends on what software you're running. If again you're sticking with the older ArcMap, ArcCatalog stuff, then Intel, up until this new version, the new CPU from AMD, was the best way to go for the Esri product line. Now with this new 5000 series, and I don't have one.
Scott has clarified what working best with Pro.
Working best with Pro. Right now, if I had to choose, I would say the new 5000 series AMD processors would be best because they have a greater core count and they all support multi-threading. So that would be my recommendation. Now, when the new ones come out from Intel in a couple of months, that may change. But right now, I would say the new 5000 series AMD would be the best. If you look at the older Ryzen series from the beginning to the 3000 series, which was the one prior to this, and the Intel, I would say it was neck and neck, with Intel having some benefit over the earlier versions of Ryzen.
All right, Scott says thanks. We'll let you continue on now. Keep those questions coming, folks.
Yep.
I'll interrupt him again if we have more.
So good questions, appreciate that. So we were talking about memory and I said 16 gigs, the minimum. I wouldn't go anything less than that. Now, the other thing here that's critical, especially if you go with an AMD Ryzen CPU, is the clock speed of the memory. So even RAM has a speed in which it writes data back and forth. So with AMD processors or CPUs, they typically work much better with faster memory. So the faster you can get it, 3200 or higher, the better. Intel has been less impacted by the speed of the memory, at least with their 10th generation and back. So it is not as critical to have high speed memory with an Intel processor. You still don't want slow memory, but the performance increases you get and stability increases you get with higher speed memory are not present with Intel like they are with the AMD processors. So that's another important thing to note when you're picking your system is if I'm looking at an AMD powered system, then I want to make sure I pick RAM that is the highest speed I can choose. And it should be part of the spec when you're picking from the vendor, Dell, HP, or whatever, is not only how much RAM, the 16 gig, but what is the speed on it, and that kind of thing. So you want to make sure that that is dialed in as well. So said, if I'm looking at AMD powered workstation, I'm not going to go with anything less than a 3200 speed memory kit. If I'm working with an Intel, then 33 speed is fine. If you can get faster, that's fine. It's just obviously the faster the memory, the more expensive it gets. So that's something to keep in mind. So a lot of this also depends on what budget you have to work with. Although AMD processors tend to cost less than an Intel processor of close to equivalent capabilities. Okay. So that leaves us or gets us down to storage. So when you're looking at hard drives, it used to be easy. You pick a hard drive, you pick the size you need of the hard drive, and necessarily how many you wanted, and you were done. Nowadays, that's not the case because we have traditional hard drives to choose from. We have what have now been kind of dubbed traditional solid state drives. That's what SSD stands for, solid state drive. And then we have something new, which is the PCIe NVMe drives. So you can see pictures of all of these here. So let's see, I'm not sure if this one right here is a traditional hard drive. This one is the NVMe PCIe drive, and this is the standard traditional SSD drive. All of these have their place in the world depending on what you're trying to do. So what I would recommend for a GIS workstation is you want at least your boot and application drive to be one of these PCIe NVMe drives. As you can see, it kind of looks like a memory stick here. They have the best performance out there. They're at least 2 times or more as fast as even a traditional SSD. Depends on which version you get with that. So you want to make sure that you get one, I would say probably no smaller than 500 gigabytes. If you can get a terabyte, that's even better. But you want to use this for putting all your programs, your operating system on as your page file for your operating system so that the system runs fast. Then if
your 5-minute warning, okay?
Oh Lord, this has gone by fast. Okay.
Yeah.
Otherwise, you want to make sure you have an SSD in there. You want to try to avoid hard drives, traditional hard drives as much as possible, unless you're doing some sort of archival storage on your direct system. But these are the 2 types you really want to focus on. I practiced this and I got through a lot more of this thing. And then, let's see. Lastly, we want to look at our display. And for the most part, you're going to look at what is used to generate the display on your computer. You generally know you need monitors and multiple monitors, but you really want for a GIS workstation to have a dedicated GPU. This can be one from AMD or NVIDIA. Intel is currently working on some right now. The specs we've seen on what they're working on haven't been great, and I wouldn't recommend what I'm seeing right now from Intel, but AMD or NVIDIA, any of their newest cards, so the 3000 series from NVIDIA that just launched a few weeks ago would be wonderful if you can get them. They're currently mostly sold out. And AMD and the 6800 GPUs they're about to release, and that's what you see pictured in up here at the top. Either one of those are going to be great. I would not necessarily right now run out and try to get the previous generation RTX 2000 series card from NVIDIA at MSRP because you can go find a bunch of used ones a whole lot cheaper because the new 3000 series came out. So you definitely want that dedicated graphics card. You want to make sure it has the right ports on it, VGA, HDMI, DVI, display ports. Most of these new ones are only going to have display ports and HDMI. So you'd have to double check your monitors to make sure what they support on there. And you want to make sure you pick one that has at least 6 gigabytes of video memory on there, which again, most of these new cards coming out are going to have a minimum of 6. Some are going to have 10, 12, 16. I think one of them even has 20 gigabytes of video memory on it. So these are important, again, important things to note. So somebody asked, what is the spec of my computer? So I'm going to get that out there to you real quick. So I'm running a Ryzen 7 2700X CPU, which is 8 cores and 16 threads. I have 32 gigabytes of 3200 speed RAM. I'm running a 500 gigabyte NVMe boot drive. I have a 1 terabyte SATA SSD for active project use, and then I have an internal 700 or 7200 RPM standard hard drive for archival backups and things like that. And my video card is a NVIDIA 2070 Super from Asus. It's an ROG Strix card.
Excellent.
So great. Any other questions, or we have time for any? If not, they can always email me.
If you got one or two, we're supposed to stop at 2:45, but I don't see anything coming in. So with that, I guess we're going to thank you very much, Tripp, for presenting for us. We really appreciate it and hope to see you in person very soon.
Me too. Looking forward to the day we get to all get back together. I miss my SHRUG family.
We miss you too. Thank you, everybody. Thanks, Tripp. And the recording of this session will be available. Thank you.